We are going to look at just a couple more examples to wrap this section up. First of all, we need to talk about the average value. So the average value of an integrable function f on some interval a to b. So the notation that we're going to use is f bar. F bar is equal to 1 over b minus a. So b minus a, that's just the length of the interval. So 1 over the length of the interval times the definite integral from a to b of f of x dx. So really what we're doing is we're taking that net area and dividing it by the length of the interval. Here in this case we're multiplying by 1 over the length of the interval, but you could also just divide by that. So really not a whole lot of new stuff here. We're just going to be looking at, okay, let's evaluate this definite integral, and then, oh yeah, at the end we will divide by the interval length. So if I want to find the average value of f of x equals 1 over x on the interval 1 to e, so let's see here, I would have 1 over b minus a, so 1 over e minus 1, times the definite integral from 1 to e of 1 over x dx. So this piece right here, I can, if you can simplify it, go ahead, but 1 over e minus 1, that's not going to simplify in any nice, meaningful way, so we'll just leave it as 1 over e minus 1. And then we're just evaluating this definite integral right here. So let's see, first I need my antiderivative, which would be natural log absolute value of x, evaluated at e and at 1. So I'm going to go ahead and pull this 1 over e minus 1 outside, and then apply my fundamental theorem of calculus. Let's see, I should have natural log of e minus natural log of 1. And notice here in this case, I'm not writing the absolute value since e is already positive, 1 is already positive. I just don't need them. So let's see, I should have, 1 over e minus 1. Natural log of e, that is 1, minus natural log of 1, that is 0. So I have 1 over e minus 1 times 1, which is 1 over e minus 1. So this is the average value of that function. So what we're actually finding is the average y value of our function on a particular interval. So this is the average y value of our function. One last theorem to talk about here. So here we have the mean value theorem for integrals. So it is different than the mean value theorem for derivatives here. It says something just a little bit different. It says let f be continuous on the closed interval a to b. There exists a point c in a to b such that f of c is equal to f bar, which is equal to, whoops, I have a typo right here. This is the average value, 1 over b minus a times the definite integral from a to b of f of t dt. So if you think about what average value says, average value just gives you the average y value. So if I was to graph just like a linear function, just to work with something nice here, and let's just work on 0 to whatever that point is. My average value would be right here. If we are working with a continuous function, essentially all this is saying is that the y value of your function at some point has to be equal to your average value. So if you graph your average value and you're working with a continuous function, what it's saying is that, this black line right here has to cross that red line. That's really all it's saying. So I have a few things that I need to do here if I want to apply the mean value theorem for integrals. So here I want to find the points on the interval 0 to 1 at which f of x equals 2x times 1 minus x equals its average value on that same interval 0 to 1. So first thing I'm going to do is find its average value. So let's see, its average value 1 over b minus a. This is 1 over 1 minus 0. times the definite integral from 0 to 1 of 2x times 1 minus x dx. So let's evaluate this first. This is really 1 over 1. This is a little bit tricky. I would just go ahead and distribute that. It's made to look like it might be more complicated than it actually is. Remember, we can simplify things inside of the integral. We can simplify that integrand before we find our antiderivative. So let's see, we're working from 0 to 1, and I have 2x minus 2x squared dx. So 1 over 1, it's just 1, we're multiplying by 1. This really isn't going to do anything for us. If we multiply by 1, it's not going to change anything. So really I'm just looking at what is this antiderivative. So let's see, I want to find my antiderivative, which would be x squared minus 2x cubed over 3, evaluated at 1 and at 0. So let's see, x squared, that's going to be 1 squared minus 2 times 1 to the third over 3 minus 0 squared minus 2 times 0 cubed over 3. 0 squared is 0. 2 times 0 to the third divided by 3, that's 0 as well. On the left-hand side, I've got 1 minus 1 to the third will be 1 times 2/3, that's just going to be 2/3. 1 minus 2/3, this gives me 1/3. So this is f bar. This is my average value. This is the average value of f on the interval 0 to 1. So I found the average value. What I found is this piece right here, that f bar. Now I'm going to find the point C where my function is equal to its average value. So I'm just going to be taking my function and setting it equal to the average value. So I'm going to take my function, f of x, and set that equal to the average value. Or you can say f of c if you want to keep the notation consistent. I usually just leave it as x. So our function was 2x times 1 minus x. 2x times 1 minus x is equal to f bar, which we said was 1/3. So I'm going to solve this equation. On the left-hand side, I am going to have to, let's see, distribute. This will be 2x minus 2x squared is equal to 1/3. And then I'm essentially just trying to solve this equation. So this is a quadratic. The easiest way to solve a quadratic is to set this equation equal to 0. So 0 is equal to, let's see, 2x squared minus 2x plus 1/3 is equal to 0. I don't like this fraction. You could leave it there if you wanted to, but I just prefer not to deal with those. So I'm going to multiply everything by 3 on both sides of my equation. So 0 times 3 on the left-hand side, that'll give me 0. Let's see, I should have 3 times 2, that'll be 6x squared minus 6x plus 1. And let's see, will this factor nicely? I don't think so. Unfortunately not. So here, you can try and factor it. I don't think it's going to by the looks of it. You can try to complete the square. Generally, if I can't factor, though, I'm going to jump straight into the quadratic formula. So let's do that. And of course, we all know and love the quadratic formula. That's x equals, let's see, opposite b plus minus square root b squared minus 4ac, all divided by 2a, which of course we all remember. So let's see, opposite of b, so that's positive 6 this time, plus or minus square root negative 6 squared minus 4 times a is 6 times c is 1 divided by 2a, that's 2 times 6. So 6 plus or minus radical, we'll have 36 minus 4 times 6, that'll be 24 over 12. So let's see, 6 plus minus radical 36 minus 24, let's say this is 12 over 12. And then, of course, we can simplify that. We can say that 6 plus or minus square root of 4, square root of 3 over 12, which is 6 plus or minus 2 radical 3 over 12. And then if you really want to, this is divisible by 2, this is divisible by 2, this is divisible by 2. I'm going to divide everything by 2 here. So that'll give me 3 plus or minus radical 3 over 6, which is not a particularly nice number to work with, but it is, and actually it's 2 numbers, right? I'm almost done. I swear we're almost done with this problem. The last thing I need to do, if we go back and look at the directions, we said, hey, find the points in the interval 0, 1. I need to find out which of these 2 numbers, or if and maybe both, fall in the interval 0 to 1, because that was the interval that I care about. So here I may just want a decimal approximation that will help me figure that out. 3 plus radical 3 over 6. Let me get my graphing calculator out. 3 plus square root of 3. Oops. 3 plus radical 3, take that result divided by 6. So here I have 0.79 if I round to 2 decimal places, which means that this is one of my solutions, because this falls into the interval 0 to 1. I'm also going to look at 3 minus square root of 3 over 6. I believe this will fall in there as well. Divided by 6 here, yep, 0.21. 0.21, that's also between 0 and 1. So this is also a solution. If we had ended up with something that fell outside of this interval 0 to 1, then that would not be a part of my solution. I would just take the numbers that fall between 0 and 1. And if we didn't end up with any numbers between 0 and 1, that means we made a mistake somewhere along the way. So this is a little bit lengthier than just finding the average value, because here we not only need to find the average value, but then set that equal to our function and then solve that equation. If we have more than one solution like we did here, so if we have more than one solution, look at those numbers if you need to get a decimal approximation and see which of those values fall into your interval. If there are any that do not fall into that interval, then those are not a part of your solution.